Please welcome Florian Plank.
Can you hear me all right? Yeah, that's an ungrateful job last talk before the lunch break. I'm gonna try to keep it short. Yeah, my name is Florian. You can find me online under Polar. You cannot find me on Facebook. Yeah, I wanted to show you one thing. This is my first time in Poland, and it's been really awesome. People are super friendly here. But the best thing that I've found so far is this.
Pretty accurate.
Yeah, that's brilliant. There's nothing I can say about this. Yeah, so I was supposed to warn you about a few things. This is not really a soft talk, but it's also not like a purely technical talk in the sense that there's, as the title suggests, going to be a lot of like half-truths, experimentation, and guessing. Or maybe not guessing, but it's not particularly like the kind of thing that you want to take home and then use in your product. And yeah, there's going to be a lot of CoffeeScript code. So I'm really sorry if you don't like CoffeeScript. Yeah, I can understand you, but I prefer CoffeeScript over JavaScript. So how did I come to this? How did I come to this topic? I was watching a video of a talk Aaron Patterson gave, I think, at Aloha RubyConf, and he basically suggested that we should start taking better advantage of the browser, amongst other things. And he worded it somewhat suggesting we should steal and lie and cheat more, making better use of the resources that we have. And so that's where the title comes from, and that's where the inspiration for this talk comes from. We have just had 2 big releases. Excuse me. And it sort of tells you how old this community is. It's not very old, but Ruby is nearing 20 years and Rails 10. We've been doing things like for a long time in the same way, in a very similar way. And I'm not saying that should necessarily change completely, but I would like to suggest that there might be maybe some things that we could try, new things, that mainly involve the browser. And I would like to give you maybe if not a perspective, but at least some ideas that you could try and think about and maybe find some ways to improve your applications. And then there's like these indicators for myself that there's a demo here. And you know what they say, that you really shouldn't do any demos or live coding because they tend to go horribly wrong. And I don't have the problem with the demo that I'm going to do now because I know it's going to fail. Like I'm at least 80% sure it's going to fail. So, but it actually doesn't matter. You're going to see in a second, hopefully why. So what I'm going to do. All right. So what I've built here is this. This is actually going to be quite difficult. I've built a small application that is supposed to measure your heart rate in the browser. And I was just going to do this now. Wow, this is really... So I put my thumb on the camera. I need to... crap. This doesn't actually fit. Sorry, I gotta... This is seriously difficult. All right. Good. So it failed. Hooray. So the reason why I'm showing you this, actually I can show you first why it failed. The problem is that the data is too noisy and you just can't, I cannot detect the heart rate well enough. And I'm going to tell you later on why, but this is not actually the point here. The point is that I was able to do this at all in the browser. So why did I do this? I came across an article taken from this book, Exploring Everyday Things with R and Ruby, and it really spoke to me. I don't know, have you read this article, the blog post? No? I can highly recommend it because it manages to take a fairly complex process and describe it beautifully simple. And I'm coming from a front-end background, and this really spoke to me because it has this very human problem that you try to solve, which involves hardware, and it does it like with an ease that is incomprehensible. And so I figured actually all the tools that I have that are required to do this, I have in the browser right there. So why not? And it turned out it's actually doable to do just that in the browser. And just to quickly explain the tools that they were using, they in order to get this done the way they did it, as described in this post, would require you to have a good camera that would like take a series of images. Then you would read the images into your machine, and from then on, basically the code that was described here would take over. And it was like a whole, you couldn't do it in one flow. While in the browser, I can actually do it from beginning to end. I have all the tools right there. I got like my camera axis, and I got the code that I need to execute it. So how does it work? Not well. Well, you saw that it doesn't work very well. I'm still going to describe to you how it works technically because I think it highlights a nice point. You snap a few pictures with the camera, a few frames, and read them into a canvas. So here's the code that, can you see that? Almost. That is not so good. Apologies for that. It's quite bright here. That's the part when I get a bit nervous because there's a lot of code there. Is this better? Yes. Right. Hooray for universal access. Okay, so we read a couple of frames using the camera here, and push them into a canvas. So this is the setup that's required. So we got the canvas here, and then we got the preview screen that you saw. We got a few methods here that are actually not very important, that keep track of if the recording has started and if it's currently running. And then here, this is a more important piece. The last line gives us the access to the camera, and that's the first thing that hasn't been possible for a longer time. And you probably know that now it's possible in some browsers. But this was sort of the key piece that made this, that gave me the thought that I would like to try that, because now I actually have access to the camera in the browser, so I can do everything in one sitting in the browser, while the guys that did that with Ruby and R had to use an external camera and then really move the files. So this is the code that does just that. It takes a stream of data that comes in and then calls a capture callback once the data is available. So this is all inverted now, but you got like a set of a set of frames that are more or less reddish. And yeah, now we got to keep track of when has the frame been taken, when has the frame been captured, and we got to read out the data that's in that canvas available. And we do that using request animation frame repeatedly until we have reached a certain condition that defines that we are done. In this case, I run this for 10 seconds. Once I have the data available, or the pixel data available in my canvas, I can start working with those. And I'm not sure, are you aware of how the HTML canvas works, roughly? Yeah? Okay, so each pixel is represented by 4 1-bit values, representing RGBA colors. So since I only need red, because I want to find out how red the frame is, I'm going to iterate over those and fetch always the red value for each pixel. It's basically very simple. And in that process, I find out how red a frame is, and how high the blood pressure has been at that point, because I got the time frame and I got the redness of that frame. So I got these 2 values. That's only 2 numbers. And now, since I've taken like an array of these frames, I hopefully get to see these peaks in the data. And now I basically, from then on, it's only math. I need to find where the peaks are, and I need to calculate how far apart they are from each other. And then I know approximately at which point there has been a heartbeat. So why does this not work as good as it should, and why don't I care? Well, the reason is that the camera basically is not good enough. The lighting conditions in here are probably not good enough. And that algorithm that detects the peaks is probably not good enough. All things that could be solved. So that's the reason why I still bothered to show you this, because I found it fascinating that I can actually go and do this in the browser. But this was the starting point. This was why I'm here. I realized that there's a lot more that we can do nowadays in the browser than we're actually doing. Yeah, in order to do this, you need to have a couple of shims in place. I just show you this for completeness sake, but if you're interested in this, then you have to look into this anyways. There's a couple of new JavaScript APIs that are not available everywhere in the browser. Prefix those with vendor prefixes. Right, this is going to be really creepy now in Word. Okay, so this got me interested. It didn't work. It didn't work perfectly, but I knew if I would invest like a lot of time, I could probably make it work, right? Actually, if someone wants to, please let me know. So I got interested. I got thinking. The way we build web applications right now is very simple in where the computation takes place. We usually just display interface and handle the user interaction on the client or on the browser, and all the heavy stuff happens on the server. So I started wondering, could we maybe do something about that? Could we maybe take better advantage? Because it seems that the browser actually can do a lot for us. I get to do all of these crazy things just now, and it's just a browser in the end. This is Chrome. So I started wondering, how powerful is it actually? Like, what can I actually do there? So I wrote this little script. It's a very naive script, very simple, which basically guesses MD5 hashes. And so this runs in the browser. Why is it written like this? Because I'm able to almost identically reproduce this in Ruby, so I can see how this would perform on the server, approximately. This is not scientifically at all relevant, but I wanted to see what would happen, right? And it turns out nothing good. I was very disappointed, because I found out that after 4 characters in this case, the browser just froze up and broke. And that was the point where I almost gave up, and that was actually just very recently ago. And I thought, oh crap, all of this won't work. This talk is basically for shits. So I started thinking, maybe I've approached this wrong. Maybe we should take a step back and make it look like we would do the heavy work on the client, hence stealing and lying and cheating. And I started thinking, so what are the kind of problems that usually take up a lot of resources on the server? What are the kind of problems that take a lot of time on the server, and how are they represented on the client? And it turns out, I think they almost always start here, or a lot of them. And I'm talking about the very basic web applications. Very often, the things that are taking up a lot of resources on the server are having something to do with media. Not all of them, but very often, if there is some kind of interaction happening on the client, then they might have something to do with media. So I figured let's try to solve some problems that are a little bit closer to the interface. Let's not try to solve the hard math problems on the client, but let's try to solve some problems that are not currently solved on the client, but on the server, but a little bit closer to the UI. So one of the first things I tried was this. I'm not sure if no, it's probably really hard to recognize. You maybe know there's like a little piece of interface in iMovie as a video scrubber. You got like a thumbnail and you basically drag over with the mouse and you get an overview over like a few frames, what's happening in the video. You just, from beginning to end, you get like an overview. So I was wondering, that's the kind of thing that usually you would upload the video and then you would process the video and take out the frames and then send the frames back and then display that on the browser if you would want to do that. So I was wondering, could you do that maybe on the browser? So I did that. This works just fine. So now, why is this relevant? Why am I showing you this? I didn't actually upload this at all. Nothing. This never went to the server. This has all happened in the browser. So why do I think this is relevant? We can now go, and we could go and tell the user that we have done all of this on the server already, and it happens almost in an instant. While actually nothing has happened yet. We might have pushed this to the queue somewhere, and it's going to be processed sometime later. We might not do it at all on the server ever. Maybe we do this anytime the video is loaded. It actually didn't take that long, so we could just do this in the interface. Something that's very computationally heavy to do if you have a lot of videos being uploaded. So how does it work? Well, you got a file input, and I got this output container, and then we got a new JavaScript API that provides temporary, like object URLs. We can push in like a file or a blob of some kind, and that makes it possible to get instant access to the file that we have just opened via the file input, and that's something that hasn't been possible for a long time. And that makes a lot of things possible now that we used to have to do. Used to upload a file first to the server, then process it somehow, then push it back down. Now we can do all of this in the client while we are handling something else on the server. This is the API for that. This API, this method has only two methods for that API. You create the URL and then you can revoke it again. So we fetch the video object, and once the user selects a file, we create an object URL, and then we just load the video. in the background. We don't actually show the video. Once the video is loaded enough that it would be possible to play through the video, we start to extract the frames. So this method calls itself. We just step through the video in a predefined rate and just take one of the frames out, push it into a canvas, create a new canvas object, and push the canvas back into the output container. And from there on out, it's just a bit of JavaScript or jQuery magic required to make the scrubbing possible. What are the potential issues? Not all video formats are supported in all browsers. Not all browsers support Canvas, and not all browsers support JavaScript or have JavaScript enabled. Another problem. This is a small application that I'm working on the side, which allows annotating image files. And I built that with Dragonfly because I wasn't quite clear when I designed the application what kind of image sizes I would need, and that library allowed me to define them on the fly. And of course, that's fairly short-sighted, and nowadays I know what the image sizes are, and the whole image uploading, due to my previous choice, takes a lot of time. As you can see here, there's already like 2 different image sizes, and here's a third one, the full image size. So I need a lot of different sizes for those images. So I was wondering, could I solve that in the browser better? And again, this is the same thing, and it happens in an instant. It's super fast. So now what I'm planning on doing is I'm planning on uploading the image, starting the upload of the image, and at the same time displaying the image already in all the places where I need it. Right? That's going to make the user interface a lot more responsive. I'm lying to the user. The image is not actually on the client and the server yet, and if something goes wrong, I might have a problem and I might have to deal with that. But it's going to improve the user experience a lot, I hope. How does that work, or how could it work? I'm assuming this could be implemented in form of a jQuery plugin, for example, which just runs through these images, detects how big they should be, what's the source, and then just uses a canvas object again to crop the images. There's a canvas method that makes this all possible, which takes the source image and then the target destination, with origin and size. So you could make almost any kind of option possible. You could define where the gravity of an image should lie, if it should be zoomed or not. And that's the kind of thing, that's the kind of thinking that I think we would benefit of a lot. If we would start just consider these kind of operations that we used to do on the server because we're just used to doing it that way, and see if it's possible to maybe just do them in the browser while we're doing something else. Why could this fail? Well, again, Canvas might not be supported, JavaScript support might be missing, and so forth. Okay, so now I have a couple of examples, and I think they work fine. They involve a lot of, half-truth and lies. But are they really performant? You saw the video scrubbing still took a while. It's still not as fast as I would like it to be. And in that case, I'm going to come back to the first example that I showed you with the heart rate measurement. And what I didn't show you is that when I started building this, there was a lot of frames being taken in those 10 seconds. A lot of frames are captured, and it took actually a long time to process them. So I started looking into web workers to make this faster. And I found out quite soon that if I try to process a lot of frames at the same time using workers, the browser would crash because the browsers have a web worker limit that you cannot exceed. And that was sort of bothersome, so I started writing some counters to make sure that they wouldn't exceed it, and then start another batch after that, and so forth, and it got a little bit cumbersome. So I wrote a small library around that. It's not released yet, but it should be any time now. It's called Orange, and it basically takes care of this bit of code that you saw earlier. Yeah, just gonna. So how do you use it? You just require the library, and then create a new job set for the jobs that you want to perform. And in order to keep track of when the whole set is being completed, you get some callback events that you can hook into. And then you basically just define a new job, pass in some data, define what the job is called, and get callbacks as well. And then just perform the job, and you can push the job into the set. The set is basically just taking care that we know when the whole batch is being processed. You wouldn't need to use that. And Orange will take care that you don't exceed a certain amount of workers. And you can define how many those are. And it will take care of a couple of other things and provide a few niceties for you. The workers currently look like this, and I'm not very happy with that right now. But there will hopefully be a solution for that soon. So basically, this is being defined in an extra file. That's currently how the workers work. There's something called an inline worker existing, but I don't think you're going to support this for a bunch of reasons. So what this does is it basically performs this piece of code in parallel with a bunch of times, a predefined amount of times. So I can just, while I capture the frames, I push them into the job set, perform the job, and once I'm done with all the frames, I can start calculating the intensities for. I can start processing the data that I received. What I would like to do with that in the future is I would like to provide a API for the workers, so that you would just import a script and have a nicer API that would allow you to define the workers, because that's still a bit ugly. I'm considering persisting the jobs on the client. That's a bit questionable still. And you can see, so this is right now this is the point why I'm talking to you about this, is if we end up here, then we can start thinking about taking some more work from the server and moving it into the client. If we were able to make sure that the queue will always be resolved, even if the tab is closed and the user returns on a later point. But these are all a bit questionable. It would be nice to provide support for browsers that don't support workers. Nicer interface for the queue and some custom events. And currently, if the job fails, it fails, and you get an error thrown, but nothing else. So why are we not doing any of these things right now? Why are we not doing much of these things right now? We basically don't trust the user with this. Something can always go wrong. On the server, we have at least somewhat control over what could happen. On the client, we don't. Something might break, and the user might leave. Something else might go wrong. We can't really do much about him, at least him leaving. There's a couple of things we can do to sort of solve this problem, but not much right now. And and then to return to the persistent queue, it might be possible to store the state of an operation, but there's limits to that in size, and there's other limitations. I think that won't be solved in the near future. Still, I think it shouldn't keep us from trying these things. Browser limitations. I mean, IE is a bit. It's starting to not be so true anymore. Or it's not that true anymore. But the browser implementations of different things are very, very different, and there's some bridges there, but there's still a lot of problems to solve before we can do these nice things that I just ran in Chrome. But I would like to encourage you to take these possibilities and consider them, and maybe take like a fraction here or there and incorporate them into your apps. And to make the user experience a little bit more snappy, and to maybe take some load off your servers as well. There's a lot of new great JavaScript APIs around, and I think it's worth taking a look. That's it.